So this will be the solution to assessment 3. As with all the other assessments, there's very little value in having just watching the solution video itself. Especially in this one, it's much more valuable for you to complete the assessment yourself first, and then if you get stuck along the way, you can look through the solution. Especially since this one is very hands-on. So for this one, you need a couple of pieces of software. I believe if you get Wireshark nowadays, it'll come with npcap, so there's no need for it. The one thing that you do want to avoid is make sure that you don't install WinPcap, which is the older standard. So Wireshark is a packet analyzer. It's used to inspect packet logs. And in order to create a packet log, you need a packet capturing or sniffing library. And that's what the npcap and also what WinPcap is. But the WinPcap one is very old, so it's not used anymore. So you need the modern version, which is npcap. If you're using like a Mac or something, you're going to be using libpcap instead, but that also comes pre-installed with Wireshark. So, right, the reality is if you just install Wireshark, you'll probably be fine on most computers. Okay. There's some additional settings that you might have to set up for Macs. This, I don't really know much about it. This was just told to me by other students who were going through the process using a Mac. In addition, we'll need a tool to create TCP requests. Okay. And the tool that we'll be using is called Netcat, and the version of Netcat that we want comes with the MOBA Xterm application. This is a Windows-only application. If you're using a Mac, I believe you already have the command nc, so you can just use the command nc from within a terminal window, and it'll give you a similar output. There might be some slight differences, which I'll explain as we get there. But the idea for this is this tool that we're going to be using. So MOBA Xterm is just a tool that allows us to do various types of protocols like SSH, SFTP, and one of the tools built inside of it is the Netcat tool, which allows us to make raw TCP requests. So those are very low-level requests. So that's going to generate TCP traffic for us. And then since there's going to be a server listening for the TCP traffic on the other end of the request, we'll probably get a response back, and Netcat can handle that. Also, we'll be using a sequence diagramming tool, which is this one over here. This is the same one from the demo videos. And this will be used to make sequence diagrams. Well, this will help us make TCP level sequence diagrams. So you can use the sequence diagrams for various other purposes. In later applications, we'll be using it to make HTTP requests. But for this assessment, it's going to be using for TCP requests. In addition, because this assessment is the first one that actually requires an active internet connection, you'll need that as well. As we're finally sort of departing from sort of the theoretical application, then going into more applied side. Okay, so right, I'm gonna assume that you've completed the readings. These are actually very important to read through to learn the APIs for each of the methods that we'll be using. But the first application that we're creating over here is a Datetime client. Okay, so we want to create a piece of software that is able to collect the day and time from a server. In this case, the server is time-a-g.nist.gov. which is a government server that performs a lot of stuff, but one of the things that it gives to us is the ability to get the current date and time. So we query this server on a specified port, we will get back the date and time. And so the first thing we're going to do is we're going to use Wireshark to show those packets being captured, the date and time being sent out, the date and time requests being sent out, and the response that we get back. And it should model what we've seen so far. So we should see a 3-way opening handshake and a 4-way closing handshake. All right, so over here we have Wireshark started up. My actual internet connection is Ethernet in this case. This is wired computer, but you might see something like wireless network connection, where you'll see traffic. So if you actually click on the network that you use primarily, and you click on the shark icon, that will start capturing traffic. And over here we can see that there is some background traffic. Okay, so most applications will have some background traffic, and the amount of this that you have will vary. Usually it's a decent amount. The problem is that this is all the traffic that's coming out of your computer, every single bit of it. So it's way too much to make anything useful out of it. Okay. So we're going to click on the stop icon to stop capturing packets. And then I'm going to click on this X icon to close the capture file without saving. Okay, because this is just random traffic on my network. It's not important. Okay, so I'm going to continue saving and go back to the home page of Wireshark. So using the same technique, I can capture various, I can capture traffic on various adapters on my computer. Okay, so my computer seems to have multiple adapters. Some might be actual physical adapters, some might be virtual adapters. The one that's a bit interesting for us, not right now, but later on, will be the adapter for loopback traffic. This is a special adapter that's used when you want to capture traffic that you sent to yourself. Okay, there's a special loopback address called 127.0.0.1, and in that range, you can send messages back to yourself. Okay, and so we'll be using that later on to sort of test applications. So if we need to build a client and a server machine, we can just have our server testing on IP address 127.0.0.1, and then our client can message that IP address, and the operating system takes care of it as if it were actually going out to the internet. Okay, so we want to make a request to the domain nist-a.g.nist.gov, and the protocol that we're going to be using is the Datetime protocol. Okay, let me see if I can find that Datetime protocol. Okay, so this is the Datetime protocol. So this is what I would call one of the 3 sort of toy protocols that were invented around the time in 1983, when the internet was first getting standardized. And this protocol is actually very brief compared to most protocols that you might see nowadays. If you look at modern RFC documents, they'll often be hundreds of pages long, but this one is just like 1 or 2 at most. And so it's very easy to read. This RFC specifies a standard for the ARPA internet community. Hosts on the ARPA nets choose to implement Datetime protocol are expected to adopt and implement the standard. So this is a standard. It's not a very good standard because it's very ambiguous. It lets you decide how to print out the datetime. A useful debugging and measurement tool is the datetime service. The datetime service simply sends the current date and time string without regard to the inputs. Okay, so if you query the server, it's going to just send you back the datetime. It should support both TCP and UDP, but inside the instructions, I say that you don't need to worry about UDP. So we will just focus on the TCP portion. So one, datetime service is defined the connection while application on TCP. A server listens for connections, for TCP connections on TCP port 13. This is the most important part, the port number. So we're going to be listening on port 13 when we write our applications. And once a connection is established, the current date and time is sent out on the connection as a ASCII character string, and any data received is thrown away. The service closes the connection after sending the quotes. Okay, so it's going to send out the date and time if we query it on port 13. So what we're going to do is we're going to test this. Okay, the actual format of dates doesn't really matter because we're just testing that we can send the server a TCP request on port 13. And if it understands the datetime protocol and it's able to respond to it, then it's going to respond back with the date and time. So we're going to do that using the mobile xterm application. And so inside of here, I'm going to use the shell to send off a request, the built-in shell. So if you're using a Mac, you just open a terminal and you can follow the same steps from a terminal. So I'm going to click session and I'm going to click shell, okay, to open a interactive shell. And right, so in addition to the standard commands that you might have inside of interactive shells, MobiXterm in addition gives you the Netcat utility, which is abbreviated NC. So we're going to type in the command nc time-a-g.nist.gov.13, and before I do this, I want to capture traffic that comes back from port 13. So what I'm going to do is I'm going to first click on my actual internet connection. Okay, so whatever that is, the one that was giving me traffic before. In my case, it's Ethernet, and in your case, it might be something else. If you're using like a laptop or something, it'll be wireless internet connection. It's the one that typically has movement in the bars. Okay, so it's important that you click on this first, as the next step depends on, it's not ideally designed. Okay, so after you click it once, you're going to go into the capture filter bar on top and type in port 13. And again, the order in which you do this is important. So you can't type it in and get this green bar unless you click on this first. And then we're going to click the shark icon. And so previously I got a bunch of sort of garbage text that appears, and it's very unlikely that I'll get any at this point because I'm only listening for traffic on port 13, which typically is not used by your operating system as background traffic. At this point, I can type in the code. Okay, so it's going to be nc space the server name. In this case, is time-a-g.nist.gov. There's a couple of other ones if that one's not working over here, so you can use any of these. And then another space and 13. So the format for this command is nc space server space port number. Okay, so I'm going to stop the capture on Wireshark, and we will look through this data. Okay, so we have 8 segments, okay, and that actually is very, that's exactly what we need to make this connection work. So if you remember from our TCP discussion, to send a TCP request, the first thing we have to do is initiate a 3-way handshake. And so this is what we captured when we're talking to the time.nist server. So our IP address is 192.168.1.151. This is just a local IP address. And the server's IP address that we're communicating is 129.6.1.28. Okay, so if we look at the contents of this, okay, we can see that the flag that was set, in this case, the only flag that was set is this SYN flag. So this is the initiation of the three-way handshake. The second segment, we have a SYN and a ACK flag set. Okay, and then the third one, we have our ACK. Okay, so this is our three-way handshake over here. SYN, SYN ACK, ACK. And then at this point in time, our sequence and acknowledgement numbers are set to be 1. Okay, so these are also called relative sequence numbers. This is primarily what Wireshark and our application cares about. There's also the raw sequence number, okay, which is the 32-bit number that is the actual value. For most applications, unless you're building actual operating systems that need the sequence number, the actual values, the relative value is what we care about for the most part. Okay, so the segment after that is going to be the data segments. In this case, this data segment is a bit interesting because it, in addition to having a data link layer, so it's got a data link layer, it's got a IP layer, it's got a transport layer, and then we have our application layer, which is the date and time. Okay, so over here we can see the date time is, so they append some formatted characters like new lines. But if we look at the output, you can see that this is the date time string that we get back out. Okay. And if we look at the transmission control protocol, we can see that the sequence number is 1. Okay. And the payload is 51 bytes. Okay. So the next expected sequence number is 52. So afterwards, we have a 4-way closing handshake, and this is initiated by the time.nis server. So after it sends its data, it closes its connection with me. Okay, so from port 13, it's sending it to our ephemeral port, which is 50,783 in this case. So if you remember from, again, the discussion, the ephemeral port is a randomly generated port number in the high numbers. Okay, and that is used to receive responses from servers. So our client Netcat over here just asked the operating system to give it an ephemeral port for a short amount of time so it can finish this connection. And then the packets that it sends back, it sends out, it attaches this this least port number so that when the NIS server needs to respond back, it has a port number to respond to. So it's responding back, and we can see just from the side over here that we have FINAC, ACK, FINAC, and ACK. So this is our 4-way closing handshake. Okay, and you can confirm the values yourself. So, right, everything that we've discussed up until this part is actually what happens when your computer sort of sends traffic. You can look for the sequence and acknowledgement numbers. You can calculate them yourself for any traffic that you want. Inside Wireshark, the application is broken up into 3 parts. We have the segments, okay, on top. In the middle, we have the different layers, and inside of the bottom, we have the actual bytes. So this is the actual hexadecimal data inside of here. And what's nice is we can hover over each part. So that if we click on source port over here, this blue highlighted section over here, 000D on the side. So we can see that 000D, this corresponds to 13. Okay, so this if we convert this from hex to decimal, it's going to be 13. And then also, if we look at the next section, C6-5F will convert to 50,783. Okay, so we can look at the actual bits and bytes of the data inside of here. And this will give you a better understanding of the header structure of TCP. Okay, so everything that we've discussed in previous lectures is a part of this header. And you can go more high level. So you can see that, okay, this is the TCP header. Okay, this entire blue segment. And then it gets wrapped with an IP header, okay, which then gets wrapped with a Ethernet header, okay. And right, and that's the entire data on the wire would be the topmost. Okay, so you can sort of see for yourself what each of these components means. Okay, there's my MAC address, there's my router's MAC address, and IPv4. Okay, so you can look through each of the layers to see what they're used for. For the first coding part, we'll be creating an application that simulates the same server that we just used, the time-a-g.NIST server. So we're going to be creating a file datetime server-js. Okay, so over here we have a blank file. And so we're going to start off with the code from here, which gives us a very similar one. This is a echo server. Okay, and so let me just quickly go through this code and clean it up a bit, as it's a bit messier than I like. And it's also using slightly more dated syntax. Okay, so the first line, the net package gives us the ability to access TCP commands. Okay, so it allows us to create servers, create clients, etc. Okay, so over here we're creating a server, okay, using the net.createServer. And this uses this passes in a callback, and this callback triggers when a client connects with the server. Okay, so I'm gonna rename this to be connection or new connection. Okay, and I'm gonna create a function new connection. Okay, and I need to pass in essentially this same body. This C over here represents a socket, okay, which is our program's instantiation of their access to the port number. So if I want to send something out on the port the connection that I've established, I'm going to be sending it out in a socket. So this C value is a socket. So I'm going to rename it to be socket to be just more descriptive. And so I will replace each instance of C over here with socket. Okay, so this is our connection listener. Now, this, when you do net.createServer, you don't have to give it a it's very common to give it a connection listener function Otherwise, the server is not going to do anything if it receives a new connection. But I don't like this syntax because over here we have two observer patterns, and I want to continue to use the observer pattern. If I'm going to have two observers, I might as well have three observers. So I'm going to rewrite this to use the observer pattern instead. So over here we created a server, and we're not going to pass in a connection listener right away. Instead, I'm going to use server.on, and if you look at the code for the net package, on top it's got a list of events. The server has a list of events. Okay, so the server's events are close, connection, error, and listening. And over here we have error, and this is the listening one, but we have to rewrite it as well. But we're going to be rewriting the connection events using the observer pattern. So we're going to say on connection. On connection, I'm going to call the new connection function. Okay. And so what this is going to do is line 3 creates a server, and then on line 4 we attach a listener for a connection event to our server, which will call this function. And so we're going to continue this server.onError. We're going to also clean this up. We're going to say function server error, which will crash our server. Okay, so if our server sees an error, call the function server error. And then finally, we will copy this one more time. And so we have a listening event. On listening, we're going to call a server listening function. Now, this one is slightly different. Okay, so this one, when we call server.listen, it's going to listen on port 8124, and then when this takes a couple seconds to set up the server. Okay, it might take a couple of milliseconds, and when it finishes setting up, it's going to execute this callback. Okay, so this is just standard callback notation. So we still want to listen on a port number. In this case, the port number that we want to listen for is 13. But we don't want this callback over here because we're going to be using the observer pattern instead. Okay, so server.onListening, we're going to call server listening, and then over here, we're going to print our message server bound. Okay, and I'm going to clean this up a bit by moving. I think this is fine, in fact. Okay, so we have a listener on a connection event, which will call new connection when we receive a new connection. We have a listener for the error event in case our server has an error. It'll print that out. It'll throw the error. And then finally, we have a listener for the listening events, which will print out when the server has finished setting up. Okay, so let me just quickly run this. Okay, so we're going to be running node datetime server, and we'll get server bound. Okay, so that's all we need for now. We need to actually write the internals inside of here. Okay, so inside of here, if we want to simulate exactly what Wireshark had over here, then what we're going to need to do is send back the date and time. Okay, and then we're going to initiate a four-way handshake. Okay, so we need to so what the code does right now is it prints out client connected. Then it sets up a listener for the four-way closing handshake, and it prints out a message client disconnected. And then we have a socket.write hello, and then it uses this pipe method. Okay, the pipe method is a stream method that takes the input that it receives and redirects it somewhere else. Now, sockets are what we call duplex streams, so you can send and receive it. So essentially what this is doing is it's taking what it received and it's sending it right back out. And as it receives more data, it'll send it right back out. So essentially whatever the client that connects sends to us, we redirect it back to them as outputs. And so this is because the example over here that it sends out is an example for a TCP echo server, which essentially says whatever you send me, I'll send back to you. Okay, so this is actually not what we want for the datetime client. And instead, what we want is we want it to print out the date and time. Okay, so first we need to get the date and time is new date dot toString. Okay. So datetime is equal to new date dot toString. So this is going to be the string representation of our date and time. And then we are going to do socket.write. Datetime, as well as put a new line character at the end. Okay, so when we receive a new connection, we're going to send the datetime, and then afterwards, we're going to initiate a four-way closing handshake. Okay, and in fact, because we only want to do this after we're finished, we're going to socket.end. Okay, so we inside of the second parameter for socket.write, it's a callback. What do you want me to do after I finish writing this? When you finish writing this, I want you to close the connection. Okay, because these all apply asynchronously. I don't want any chance that the connection gets terminated before I finish writing. Okay, so it's going to send the date and time, and then it's going to close the connection. Now, I believe there might be some issues, but I want to test this out first, and we'll see if there actually is issues, because I didn't send out a handler on what the server is going to do when it receives a FIN request. So it might just ignore, it might only do half of the four-way handshake. So we'll test that out to see if the operating system will be smart enough to finish the four-way handshake for me, or if I actually have to write code myself to do it. So again, let's run the program. Okay, and so this server is running at this point. It's listening on so the default server address is 127.0.0.1. You can also call this localhost, and we specified that we're going to use port 13. So Now, before we actually make the network transfer, I want to capture it in case it actually does work. So I'm going to close this. And this time I'm going to be capturing on the loopback adapter. And again, you can see that this erased because I'm using a different adapter. So I'm going to, again, capture traffic on port 13, but this time using the loopback adapter. Okay, and again, there should be nothing here initially because that port is not really used. Okay, so I'm going to open up mobile extern, and this time I'm going to send traffic to 127.0.0.1, which is localhosts, or you could type in localhosts, and port. In fact, I don't want to use port 13 because this computer might have, it might also have a datetime server that's automatically set up, and I might be colliding it with right now. So I think inside the application, I told you to change it, right? Change it to 3013. And again, this is just because you may not be able to access that port number because it's reserved for systems. So I'm going to change this a bit to port 3013, and I'm going to rerun this program before. So I'm going to rerun the server. Now it's listening on port 3013. And in fact, I should probably change this a bit. Cons port equals 3013. On port. And we'll run this again later. Let's see. So in Wireshark, I'm going to go back and change this port number to port 3013 so that I capture on the right location. Okay, so now I'm listening on port 3013 for traffic. I'm going to generate traffic using Netcat. Okay, and so over here I see 9 segments, so there's one extra one. Might want to, well, let's see what happened. So let's stop this capture and let's look through the segments. So over here I did get back to Datetime. It's slightly different formats inside JavaScript format, so I know it worked. Maybe I should add a message or something. New clients connected. Okay, so in the future I can see messages. But let's look through the segments that was sent out. Notice that the source and destination are the same because I'm just communicating with myself. Okay, so over here we have three-way handshake. That's not particularly interesting. And then we have the message that's sent out. So this message is sent from port 3013 to port 50,821. So after I made the connection, the server, okay, on port 3013 sends a message to the clients, and the client in this case is the Netcat application. And it receives it on port 50,821, which is again an ephemeral port. And then upon receiving this message, it responds back, it acknowledges that it received that segment. So it's sending back that I received this segment. Okay. And I believe, right, that's this one over here, message 5. I believe the reason why we didn't have it in the other scenario where we only had 8 segments is because it received both the data segments and the fin segment at the same time. Okay, because we were actually going out to the internet, And the actual wait time for additional acknowledgements is about, I think, a little less than 1 second. So if we receive both of those segments back at the same time, then this additional acknowledgement does not need to be sent. Or we combine it with something else. But in this case, because we're running on the same machine, and we're simulating these requests, it's able to respond back just even faster. So essentially, it's sending a data segment. Okay, so this segment 4 is our data segment, and then as soon as it sends out, because it's the exact same machine, it's arrived. So it's going to send an ACK back. So that's why we have this additional segment. Normally, it's able to send this out and this at the same time, and it'll receive both of them at the same time because because we're operating on the same machine, that both client and server are on the same machine, we have this additional ACK that we can send back out. Okay, anyways, so this is the data segment. This is the acknowledgement for that data segment. And then these last 4 are the closing handshake. And it looks like if we don't set up a listener for a close event and it receives a fin, it will automatically terminate, which is good. Okay. So over here, we essentially have reconstructed that datetime server, although the input is slightly different. So we'll, the output is slightly different. So we'll run it one more time. Okay, so right, we are bound on port 3013. And this time, just to show you that you can also use the keyword localhost. Okay, localhost represents, it's just a more concise way to write 127.0.0.1. And we will get new client connected, and it'll send out the date and time. Okay, so the server, it continues to run as long as you don't shut it down. Okay, so I can continue to send messages to it. Okay. And so essentially this server can handle many different clients. I can go on a different machine and send a connection to it. The next step is to build the datetime clients. So the datetime client, in this case, is going to simulate this end, this request. Okay, so over here we're using the mobile Xterm application as our client, but we're going to, in the next step, we're going to build our own TCP client that does the same thing as this, but it just a much more sort of focused version that only does one thing, whereas this can sort of message any server with a TCP connection. Our more focused version can only connect with this server. For this function, we're going to be using the net.createConnection function. Okay, and this is used, so this is used if you want to connect with a server. Okay, so previously we create a server, and that server just listens for incoming connections. And then on the create connection side, we are going to connect to a server. Okay, so most of this code is given to us. We have server address. So this is the address that we are trying to connect to. This can be either localhost or 127.0.0.1. We have our port. This is the port that we're trying to connect with. This is not the port that we're going to be using. The port that we're going to be using is a ephemeral port that is randomly leased to us based on what is available. Over here, we're importing the net package so we can have access to TCP. You should probably put that on top. It doesn't make a big difference. And then over here we have 3 listener functions. I'm going to change up the syntax a bit just because I think this is a bit dated. connection data. Okay, so this is gonna handle the data events. So when I receive data from the server, it's going to come back in what we call a buffer format, okay, which is just a byte format. So I'm going to stringify that binary data so that I can print it. So I already know that it's a string format. Okay, I know it's a string format because I have toString over here. Okay, but my application doesn't know that it's a string format, so I'm going to tell it that this is a string. Okay. The next one is connection end, and this is what should I do if the server sends me a fin. If the server sends me a fin, I will print client disconnected. And finally, when the connection has finished initiating, what should I do? So this is what happens after I finish the three-way handshake. Okay, so we have a bunch of different events. We have 3 types of events over here that we can listen for, and these will correspond to the socket events. So we'll scroll up to the socket events. These will scroll, right, okay, so over here we have net.newSocket. So these will correspond to the events. So the events that a socket can have are closed. This occurs when a connection is fully closed. Okay, so this is after a 4-way closing handshake. We have event connect. Okay, this occurs after the 3-way opening handshake. Event data is this one over here when we receive some data. Okay, so this is if I receive a data segment. Drain we're not going to care that much about. End is when I receive a fin. Okay, so when the other side sends a fin packet to us. Okay, so you can see that how this code directly translates to the TCP sequence diagrams. Okay, let's go back to the. So what we're missing right now is we have all these functions, but we don't have event listeners, or we don't have the observers for them attached. So I'm going to attach the observers next. So I'm going to create a client by using the net.create connection function. Okay, and I'm going to give it a server port and server address over here. So these are the 2 values that I need to create a client. And again, there's a third value. What do you want to do when the connection occurs? But I'm going to leave this out so I can continue using the observer pattern. So I'm going to say client. So this has created a socket already. So client.on, and we're going to again go back to these events over here. So this one is data events. So I'm going to be listening for a data event. So on data, I'm going to call the function connection data. This one is listening for end. So this one is on end. I'm going to call connection end. And this last one is start. And we know that start is referring to the connect event. Okay, so after the 3-way opening handshake is completed, so that's going to be on connect. Okay. And so this is going to be my client. And this is the same sort of functionality as this one, but hopefully this one's a little bit, you can sort of see the observer pattern more distinctly in this scenario. Oh, missing this. Okay, so connection start, connection end, data, and data. Okay, so essentially what's happening is this creates the connection, and it automatically makes the connection send out, and then during that time it also will also set up 3 event listeners, and then when it starts to receive responses back, each of these 3 functions will be called. Okay, so my server is still running. In fact, let's clean it up a bit. Okay, so my server is still running. This port number that I'm going to be sending a request to is 3013. I'm going to run the client next. Okay. So again, I should set up Wireshark for this. So let's continue with that saving. And the port number is going to be the same. The adapter is going to be the same. And so I think I'm capturing at this point. I'm going to run this. And then I'm going to stop this application. Okay. So over here we have no datetime client.js. And so it's going to initiate a request to the server. So it's going to say, all right, I've connected to the server. Okay, once it's finished that 3-way handshake, the server at that point is going to send us back the date and time. Okay, receives new client connected, and sends us back the date and time. And this date and time gets received. It's a data event. It's going to print out the data. And then immediately afterwards, it's going to send us the server is going to send us a FIN request. That's going to be received, and it's going to print out client disconnected. So over here, we have our 3-way handshake again. And this is looking pretty much the same, which is good because this is what we were trying to accomplish. We were trying to build a drop-in replacement, sort of. So we have our data segment over here, which contains the date and time. We have our acknowledgements, and then we have our 4-way closing handshake. So everything's looking good. Next, we'll look at the quote of the day server, which asks us to write a TCP server according to the following specifications. So we're going to look at the quote of the day RFC. Okay. So this one is also another debugging tool. It's a TCP-based character generator service. This server listens for a TCP connection on TCP port 17. We'll be changing this to 3014 instead, just to make sure that we don't collide with the existing port 17. Once a connection is established, a short message is sent out to the connection, and any data received is thrown away. The service closes this connection after sending the quote. Okay, so it's pretty straightforward. So it's very similar to our datetime, in fact. All we have to do in this case is we can use the same exact template, and then instead of sending the date and time, we can just send back a random quote. So we'll start with quote of the day server. I'll copy the datetime server. And then instead of having a date and time, I'll just have our quote. And we'll have a list of quotes. And just for simplicity, I'll just go with some short letters. A, B, C, D, E, F, G. Okay, good enough. And so our quote of the day will be, let's see, quotes, sub map.random times quotes.length, and then we can drop, let's see, we want 0 to n minus 1, right? And then we can just drop the last, we can drop decimal places using the this binary OR operation. And that will give us quote of the day, and then socket.write, quote of the day, followed by socket.end. Okay, so that should do it. We'll change this port number to 3014, and then we'll change port over here to be port. Okay, and we should also do that for this one as well, to centralize it. Okay, so let's run this. Just to test that it works. Okay, so we're bound on port 3014. And then we'll use Netcat to see if we can get a quote. Okay, so we got a letter C back. Let's run it again. A, G, B, A, etc. Okay, so this looks like it works. In the actual assessment, you have to use Wireshark to capture the traffic, which we did previously, and then you go through the segments and you create a sequence diagram using this tool. Okay, so we'll skip that to just focus on the coding aspect. Next, we have the echo server, and in fact, this one's even easier. Even if you're unsure how to do the echo server, the example over here, this is an echo server. Okay, so you can just copy this code, but we'll build it directly. Okay, so the echo server, we have the RFC over here. So TCP-based echo service. One echo server is defined as the connection based off a application on TCP. A server listens for TCP connections on port 7. Again, we changed this to 3015 in this scenario. Okay, again, just not to collide with existing ones. Once a connection is established, any data received is sent back. This continues until the calling user terminates the connection. When a connection is initially established, nothing happens, and then any subsequent data that's received is sent back. Open up a echo server file, and again we'll start off with the datetime server as our template. Okay, because everything outside of here doesn't really change. It's just the connection function that we care about. Okay. So when a connection occurs, the specification says that once a connection is established, any data received is sent back. Okay, so this connection represents our connection with the client. And the client is going to send us back data intermittently. Okay, so we don't know when they're going to send data. So what we want to do is we want to, well, there's a couple of things we can do. We can set up a listener. We can say socket dot on. Okay, so over here, this is a socket object. That's why I renamed it from C to socket to be more explicit. And for sockets, okay, for sockets we have special events. We have close, connect, data, drain, and error, and so on. Okay, the one that we care about in this case is data. When we receive data on this socket, we want to do something. Okay, so in this case, when we receive data, the RFC specifies that we need to send that data back to the client. Okay, so we're gonna write a function data handler, and then in our case, our function data handler it is gonna do socket.write whatever data it receives, it's going to write it back. Okay, so any data that it receives, it's just going to, on the same connection, write it back. And it's going to continue this until it receives a termination request. So we need to also listen for a end. Socket.onEnd. Okay, when we receive a socket.onEnd, then we'll call a end handler. And in this case, we're just going to do socket.end to terminate the connection. Okay, so in this case, when we connect, we set up, we first print out a new client's connected. We set up a listener for data from that client. And in this case, when we receive data, we just write it back to them. And we also set up a end listener when they send us a fin request, and we terminate the connection. So let's run this. Okay, so now we are bound on port 3013. And Netcat localhost. Let's double check which port we're using. So this one should be port 3015. Let's just fix it so that we are as accurate as possible. Although it doesn't really matter. Okay, so Netcat localhost 3015. So we've connected, but we haven't sent anything yet. So we need to send a message like hello. Okay, so we can see that that message gets hit by the server, and the server sends us back a message. So in fact, we can be a little bit more explicit about what we're doing. New data received. Data, and then I'll also put one for fin received. And I think this is one of the main reasons why I wanted to use Netcat. I believe Netcat will send fins automatically in certain cases. I don't think in this case it will, because we're keeping the connection alive. We don't explicitly say socket.end over here. I believe if I push Control-C, it will send a fin request, which will trigger this end handler. And I'm not sure if other versions of Netcat do that, but I know MobaXterm's version does. So I'm gonna disconnect over here. Clear this, we'll save this. And we'll restart this. Okay, so we're listening on port 3015. We're sending a message to port 3015. So we've connected at this point. Okay, so when essentially what the server is doing is the server's, when we set up a listener, it's listening on this port number, and then when the connection fires, this event fires, it calls this connection, and this will create a socket. This creates our connection to this server. Okay, and it's important to know that you can have multiple connections. So over here we only have one sort of echo server running, and over here we have a client, and that client is connected. But I can have another client. I can have as many clients as I want. So in fact, I'm going to start another session. I'm going to go to shell, hit OK. So now I have another shell open. I have the previous one open as well. I'm going to type in netcat localhost 3015. Okay, so now I've established two connections. Okay, and these are separate sockets. They're all going to have their own separate port number. Okay, and if I start sending data, okay, then it knows that this connection is different than this connection. Okay, so it knows that it knows who to respond to in this case. It knows that these connections are separate. And this is going to be important for us when we go to the last application, which is the chat server. Okay, but do note that the server is not restricted to handling just a single client. You can have multiple clients, and then essentially every time it receives a new client, this connection function executes all over again. And typically with the chat server, your job in this case is going to be to synchronize those messages to ensure that that you can handle multiple clients. Okay, so now let's disconnect. So disconnecting is Control-C. Okay, so I've received a FIN request from this terminal. Okay, so this terminal has been closed, but this one is still connected. So if I continue to type over here, let's go 987. Okay, then it's going to continue to work on this connection because only this one was terminated, not this one. This one is still connected, and essentially the connection still exists. So every time it receives more data, it's going to continue to execute this handler over here. Whereas the other one, I've closed the connection, so I can't send data without creating a new connection again. Okay, so before we move on to the last application, which is the chat client and server, I want to touch on the pipe method, which we didn't use over here. Okay, so the pipe method is not actually a part of the net package. Okay, but it relies on the fact that the socket extends the stream package. Okay, so pipe is actually a method of the stream. Okay, so if we go to stream over here, we can see that inside of stream we have pipe over here. Okay, we also have like read, and for writable streams we have write. Okay, so this is what we were using over here when we said socket.write. So write is not directly a method of the socket. There's no write inside of here. Well, actually I guess there is, but so this implements the writable method for the streams write. But I'm not sure, is there a pipe method for here for the readable? Right, so there is no socket.pipe over here, but we can use that method. I think it's just not explicitly stated, whereas write is, because it's more core to what a socket is. Anyways, so pipe does exist, but it's part of this. The syntax is readable stream.pipe, and then destination is going to be a writable stream. Okay, and so what pipe does is it redirects the input of one stream to the output of another. Okay, so over here, if we look at the examples, we have a readable stream. Okay, typically we'll call something like fs.create read stream to get to that read stream. And then if we have some file that we want to write to, we can say readable.pipe writable. Over here, we have that type of scenario where we're receiving data. Okay, so we have this listener for data, and as data comes in, we capture it, and then we write it back out. Okay, so we have this sort of flow of data that comes in and then goes right back out. And so this we can sort of simplify to be just socket.pipe. And where are we going to write it to? We're writing it back to the socket because this is a duplex connection. Okay, and as data continues to flow in, as long as this connection is alive, it's going to continue to sort of pipe it to the output. So this is a much easier way to do this. And I think it's slightly more efficient as well, because over here we have these temporary variables like data. So if we have a lot of data, it has to move into a variable data before being forwarded. Okay, whereas a pipe doesn't have to do that. It was just take the bytes that it receives and just moves it back out. So it's even, not only is it much shorter than this code, it's more efficient, because the data handler from our previous lecture has to wait for the chunk to fill up, whereas the pipe, it just forwards the bits without that. So let's run this. Let's see. Oh, so I didn't close the other one yet. Yeah, so one of the issues that you may occur is if you try to listen on 2 ports at the same time, you'll get address in use. Okay, and that's because this application has not been closed yet. So if I kill that and I go back to here and I run it again, now it's okay. Well, actually, echo server is the one I want. Okay, so now it's okay. So I just need to make sure that this one's not running at the exact same time. And then from here, I can open up an application. World, which will print back. I run the same thing over here. I can have 2 connections at once. Okay, and that data is forwarded. Now there is an issue with pipe. Before, I had this message over here that printed out new data received, and the pipe itself does not allow me to sort of modify the data. Okay, because all I'm doing is as the data comes in, I'm forwarding it somewhere else. So there's no way for me to modify that data. If I need to change the data or perform some action every time I receive a chunk, then I need to write the code like this. Okay, and I can't use the pipe. If I just need to forward it somewhere, let's say I'm downloading a file or uploading a file, and all I care is that the bits get to where it's supposed to go, then the pipe method is ideal. All right, so let's look at the final question, which is the TCP chat application. So this one doesn't have an RFC because it's not a official protocol. Essentially what we're doing is we're building a server application that can accept multiple clients. So over here we have 1 server, and we have 2 clients. And when the server is going to start up first, and it's going to print out the port numbers of all clients that connect. Okay, so over here we have server bound, and then when the client connects, it's going to say that I've received a new client at port 53010, and I've received another new client at 53011. And then the client is going to choose a nickname. Each client is going to choose a nickname, and then afterwards they can start sending messages to each other. Okay, so just like previously, we're going to start with the server, and we'll start with the Datetime server as our template. The port number, okay, so I don't think I specified a port number, so I can just use any value. I'll just use 3013 for now. So it says start with a copy of Datetime server as our starting template, and we'll need to listen for 3 events: error, listening, and connection. So we have error, we have listening, and we have connection over here. So far so good. Let's see, when the client connects, we want to print a message. We want to print their port number out. Okay, so this is going to occur when a new client connects. So I'm going to print out their port number. And in fact, I can make this a little bit more concise. Okay, so a new client is connected. Their port is socket.remote port. So socket has access to the port number that on the receiving side, what the source port number is. Okay. And after the connection, it sets up 3 listeners, then adds a socket to the current connections to an array called connections. So we need an array called connections. Gonna create an array. Okay, so essentially remember our server can have multiple connections. We saw that in the previous Echo server example where we had 2 clients that one was still connected and one disconnected already. And so inside of our chat application, our server is just going to be facilitating as a middleman between the different connections on here. So we need a way to store the connections. So we have an array connections, and then adds the socket of the current connection to the array connections. So when we receive a new connection, we print a message. Okay. Well, before we print a message, it sets up 3 listeners. Okay. So we need to listen for socket events. The socket events that we have to listen for are end, error, and data. So it's going to be socket.onEnd is our first event, and let's be consistent with this. And I'll call this connection end. The next one is error. And the last one is data. Okay, so let's see, I'm gonna call these terminate. So it looks like if I go over here, it says when a connection is established, it's going to listen for the following events. The first one is end. It's going to print client disconnected and remove that client from the connection array. So I'm going to call this function connection terminate. And then for errors, I'm going to do the same thing. This is actually a very common sort of error handling technique. So instead of just arbitrary throwing errors everywhere, if you just keep on throwing errors, it's going to crash your server. If one of my chat clients disconnects unsuccessfully, let's say they have a spotty connection, okay, that's going to cause an error event. Let's say my server has 10 people in it. Should that error event cause my server to completely sort of fall apart? The answer is no. Okay, so we don't want to always, if you're just building single person applications, then it's fine to just throw error. But if you need you need some type of reliable application that multiple people are going to use, then you need to have a slightly nicer way to terminate. So in this case, if I receive an error, I'm gonna use the same. I'm gonna try to do a 4-way handshake to close the connection. Okay, so that's why they have the same function over here. So I'm gonna do function terminate. And so what function terminate is going to do, it's going to print client disconnected. And then it's going to remove that socket from the connections array. Okay, so what I need to do is I'm going to assume that inside of this connection array that there's a connection. And I'm going to remove our connection from it. So in fact, before we do this, let's just add that connection. Okay, so as this is running, it says set up 3 event listers, then add the socket of the current connection to array of all connections. So I'm going to say connections.push socket. Okay, so I need to be able to, the idea behind this is in order for other connections to be able to send messages to each other, I need to be able to access each connection. So in our case, our connections are Pinky and Brain. In order for Brain to send a message to Pinky, I need to keep track of Pinky's connection. So that's what this is doing. This connections array is keeping track of everyone who's connected to our server. So when Pinky connects, this new connection function triggers, and then their connection moves into connections. When Brain connects, his connection also moves into the connections array. Okay, so that is taken care of. So I can move this down here, in fact. So all of this is taken care of. And we're going to move on to the end event. Okay, so we're going to print client disconnected, and then we're going to remove that socket from the connections array. So in order to remove it, we're going to use the splice function. So we're going to do connections. You can also use the filter function, but I think splice is more efficient here. And so the splice function allows you to remove a particular element from an array if you know the index. So we don't know the index of it. We just know that we want to remove sockets. Okay, because this function occurs when connection terminate is called, and that occurs when a end or a error event happens by some socket. So we're going to say that socket, okay, that socket, we're going to look up that index of, we're going to look up, so we're going to look up inside of our connection array, we're going to look up the index of socket, and then we're going to delete the first one inside of there. Okay, so the splice function allows us to remove elements from an array, and if you give it the syntax is the index that you want to start removing them from. Okay, that's called start, and then the second parameter is delete count, the number of elements you want to delete. In this case, I want to delete 1, which is the first one, and then afterwards, if you want to insert anything else afterwards, we don't want to insert anything else, so we're just gonna be done with that. But the third parameters is whatever you want to insert into that place as a replacement. So what this effectively does is it removes the socket at index wherever this socket is supposed to be. So this looks up where the index inside of this connection that corresponds to our connection, and then this removes it. If you want a slightly, you can also use the filter function. So you can say connections dot filter. What this is going to do is going to loop through each of the connections. Each connection is a socket, and it's only going to keep the sockets where S does not match socket. We're going to loop through all the connections, and we're going to keep the one where S does not match sockets. And then I can do connections is equal to connections.filter. Okay, so either of these will work. I prefer the first one because it doesn't need to create another brand new array. So I think it's a little bit more efficient this way. As you're just manipulating an array instead of creating a brand new array and replacing the old one with it. But this one should work as well. So anyways, so print client disconnected, remove that socket from the connections array. And because with the end, it's closed the connection. I think I still want to try to do socket dot end. In this case, I still want to try to have it close nicely if possible. But I don't think this is necessary. In fact, I'll move it down one line. So we'll see if it causes any problems. Next, so data. So on data, we're going to use socket.write to send data to everyone except the current connection. So this one is connection data. So this is a data handler when we receive some data. So this data represents a buffer format. And so buffer is just a chunk of data. And when we receive a chunk of data, we're going to use socket.write to send the data to everyone except the current connection. And this makes sense because I don't want to receive the same text that I just typed in. So I need to loop through all the connections except for the current connection. So there's a couple ways to do this. So I'll use a for loop and then I'll do the map function as well. Okay, so for let I equals 0, I is less than connections.length, I plus plus. If socket represents the sockets that that triggered this function, which means the socket that we received data from. Okay, so if that socket matches connections sub I, okay, so if that's the current connection, and I guess that in that case then we don't want to send data, so for everyone else we do want to send data. And then in that case it's going to be socket dot, it's going to be connection sub I, connection sub I dot write data. Okay, so we're going to loop through our connections. If the connection is not the one where we received the data from, then we're going to write the message to that socket. Okay, so that's how you would do it with a for loop. And if you're going to do functional style, then it's just connections.map. Okay, so we're going to apply a function. Well, in fact, we don't even need to use map. We can use for each because we don't need the return value of the array. So we can use connections.forEach, which will loop through our array, and it'll say, so let's call the new socket S. Okay, I don't want to call it socket because that's going to collide with our existing socket. So we're going to say loop through each of the sockets inside of a connection. We'll call it S. And for each socket, even this, we still need the if statements. So filter out the one that is not you. Okay, so there's going to be connections.filter, goes through the connections array, remove all sockets that are not you. Okay, so there's, again, a array of, let's say, 10 sockets. Remove the one that is yourself. Keep everything else. And then for everything inside of there, for each of those sockets, we're going to do socket.write data. Okay, and so this would be the functional equivalent. And if we're being a bit clean, it would look closer to this. Okay, so this first one is loop. This second one is the functional equivalent, which I prefer, so I will use this one. But again, the loop should work as well. so that is our server. So before we write our client, I'm going to test our server, and we'll use Netcat to test our server, okay? Because this is nothing special; it's just sending TCP requests. So before we build our client, we want to make sure our server works. So we'll run our server code. And in fact, I don't need two of these, so, well, not yet anyways. Chat server. So we're bound on port 3013. Do I actually print out the message that we received? I want to print out the message as well, so that I can see it. So I'm gonna do console.log data. Okay, so received data, and then do the forwarding. Okay, so I have one connection, and I'm going to do another one. Again, 3013. Okay, so you can see that I have two clients connected at this point. And if I type in hello over here, so I've received hello, and then over here, it forwarded hello to the other instance. Okay, I'm going to add a new connection again. So now I have 3, 4, and 5. And again, I'm going to connect to 3013. Okay, so I've received another new connection. So now I have 3 people inside of this chat room. And if this person types in world, then both of these should get that message. Okay, it's everyone except for my connection. All right, let's see let's see how this handles a disconnect at this point. So if I disconnect, okay, so a client has disconnected. Okay, but these two are still in the chat room. Okay, so this client number 5 disconnecting should not sort of tear down the entire chat room. The chat room should continue to work just fine. So right, if I send a message from here, then it's still received from the one remaining connection. The one who disconnected, of course, didn't get it because they stopped listening. But the program should continue. Okay, so this looks fine so far. And again, if you swap these out for either the loop or the functional style, it should be the same. So what we need to do next is write the client, and the client is a little bit harder just because it has to do with I/O stuff. Okay, so over here we start with a copy of Datetime client, and we're going to add the following code to set up a console input. So because we need to accept user inputs, we need a read line. And in order to use readline in readline as a observer pattern, we need to set it up like this: std in. And I don't think we actually need the outputs, but might as well. Just because we're we're not actually using this as a writable stream, but it's not a problem to keep it. So we need to implement connection data, connection end, and connection start, which we have over here: connection data, connection end, and connection start. Connection start will ask the user for a nickname and then call a new function chat. So we need a new function chat. Okay, so connection start is going to ask the user for a nickname. And for asking the user for a nickname, we can use readline.question. And let's look at the syntax for this. Okay, so readline.question, the text that we want to prompt the user with, followed by a callback that has the answer. Okay, that's the syntax over here for the interface, that question. So the first question is going to be what is, or choose a nickname. And we're not going to do any validation of this. People can choose the same nicknames if you want. We're going to keep it as primitive as possible. And the second one is a callback. So this is going to be their answer, and I'm going to say I'm going to create a variable nickname. And I'm going to set nickname equals answer. And then I'm going to call the function chat. Okay, so it says connection start will ask the user to choose a nickname and then call a function chat. Use readline.question to capture this input. Now what chat does is it prints out the user's nickname surrounded in braces. It waits for user input. And it checks to see if the input is the string exits. If so, use socket.end. Okay, so it looks like we can just use this readline.question again. So this is going to prompt, it's going to print out something, and then it's going to accept some user inputs. So print the user's nickname. In this case, it's a nickname. Okay, so that's going to be their user nickname wrapped in square braces. And then the function this time, the answer that they're going to send back this time is the message that they want to send. If the input is the string exits, then use socket.end and process.exit to exit. Okay, so easy enough. If I'm going to change this from answer to message. If message matches /exits, then I'm going to terminate the connection, and then after I finish the four-way closing handshake, close the chat application. Otherwise, and be careful with this leaving out this else, because this takes some time to run, and in the past this has caused problems because as this is getting ready to close, because there was no else over here, it does a socket.write, and it writes out data, and that messes up all of this because you're writing at the same time that you're trying to close. So very common mistake when people try to be, I guess, clever and just like minimize the number of if-else statements. So we're going to be client.write. Okay, so we're going to be writing to the server. And the server, otherwise use socket.write to send data to the server to be propagated, prefix the message with the user's nickname in square braces. Okay, so essentially we're going to say this user said this message. Okay, so it's going to be the same that we had over here. Okay, but we're going to add colon, this user said this message. And so this turns it into a string. It'll say something like Pinky said the message hello, or Brain said the message goodbye. And that gets sent to the server. Okay, and then we're going to call chat recursively. Okay, so after we receive a prompt over here, we're going to call chat recursively to accept the next user input from them. In fact, this should go into here. Okay, because I don't want to call chats if I'm terminating. Let's see, connection end. It says unchanged. Just print out the message client disconnects. And connection data. Connection data was supplied to us because it's IO stuff, so it's not really that important to know, but it says I'm gonna erase the line. And in fact, I'm not even sure if I need this extra part, but I'll leave it. So it's gonna erase the line at position 0. It's gonna move the cursor over there. And since we're using this cursor to function, then we can't use the VS Code debugger. I'm not sure if I need this null value here. This doesn't moves the right cursor stream. What is this null value? Stream, variable stream, x. Oh, y is the y location. Why is this null? Let me see if I just leave it out. What happens? Is it required? Looks like it's optional. Print out the data that was received. And we're going to print out our nickname again, which I'll just copy from here. So it's going to say choose a nickname, prompt the user for a nickname, and then each time it says a message, it'll ask us to type in a new message. Okay, so this is what's being sent to the server. Okay, so we're using client.write to send this message to the server, and then we're going to recursively continue to accept messages. When the server sends us data, on the other hand, when the server sends us data, and in fact, I should probably just call this socket instead of client, as this isn't really just receiving data, it's both sending and receiving. So I'm going to change every instance of client to sockets. And I'll leave this as client disconnected. Just to be a bit cleaner. Okay, so when we receive data, okay, when our socket receives data, we're going to erase the data on line 0. We're going to move our cursor over there, and then we're going to print out that data. Let's see, line 25 clears the TTY, line 26 moves the cursor to the beginning of the line 27 prints the data received, and line 28 rewrites the erased prompt. So essentially, if I understand this correctly, it's initially, okay, and there'll be like a blocks over here. Okay, and so what this is going to do is it's going to, first thing it's going to do is it's going to erase the line that I'm currently on. So it clears the current line that I'm typing on. And it moves the cursor to the beginning of that line. Okay, so before we had like a bunch of characters that, and then our cursor was over here. Okay, so we're going to move the cursor back to the very beginning of the x coordinates. And then it's going to print out, okay, so because I received some data, okay, it's going to print out that data that it receives. Okay, and then finally, it's going to rewrite that prompt on the next line. Okay, so that I can continue chatting. So every time it receives data, it erases this. Okay, so this entire line gets erased. Okay, and then after it gets erased, it's going to write the message that was received. Let's say it's from George this time. Okay, and then it's going to redraw that prompt. That's what these lines of code is doing. Okay, maybe that's why the null is important. I'm not sure if this null is necessary, but I'll just leave it in and assume that past me knew what they were doing. Okay, so let's run this. Again, I'm probably gonna need to open a couple of terminal windows up. This one. So chat client. Let's see what's missing. So this one's missing a closing parentheses. There we go. Okay, so next one, readline.question is not a function. I think this should be IO. Okay, so now it's running. Let's see if there's any runtime issues. Pinky. So there's our first chat application, and we have a new client connected. In fact, let's restart the server because it's got a bunch of stuff that I don't want. So let's start it clean. Okay, so I've received a new connection, and I'm gonna also so I've received 2 connections over here on 2 different ports. And when I send a message, it's received from brain, hello. It's going to forward it to over here where it redraws the prompts. And if Pinky sends a message, we get the same. Okay, 1, 2, 3. 4, 5, 6, 7, 8, 9, exit. Okay, and so at this point, this client has exited, and if I send a message over here, this message gets sent to nobody, but it's so that took a couple of seconds. That took I had to jump back over here to see the inputs, but looks a bit messed up, but it's probably fine. Okay, so this message is still received, but because there's no one else to send it to, it doesn't get forwarded anywhere. If I connect back, okay, then that message does get received. So one thing that that I'm not showing over here is that this is just raw TCP segments being forwarded to different applications. There's nothing special about these clients. And to show it, I'm going to use our Netcat application again. Okay, so our Netcat application, we know that this is running on port, this server is running on port 3013. Let's see, chat server. Okay, so we know this chat server is running on port 3013. We don't have any way to have the user choose a nickname or something. Okay, but right now we are connected. Okay, so we can see that we've received this new connection. And so if one of these members sends a message out, let's see. Okay, windows are a bit large. Okay, so I'll say hello new person. Okay, then we can see that we do receive that message over here. Okay, we do receive that new message because we are connected to the server. We just don't have the client software to sort of accommodate sort of generating a nickname and send, but we can send a message. So now sending a message may cause problems. Well, it may cause a problem if I don't format it correctly. But because I wrote this program, I know the format that they want. The format that they want, in this case, is square brace some nickname. Okay, so I'll say Tom, followed by a colon, followed by my message, hello from Netcat. Okay, and so if I send it like this, then both instances receive it, but I don't even have to follow this rule. I can just say whatever I want. Okay, and that data will be sent even if it doesn't have the prefix in front of it, because all the server is doing is treating that prefix as part of the string. Okay, so there's not much special about these applications. They're just arbitrary TCP applications, and you can use a different program like Netcat to connect to a server and start sending data. Okay, so that's it for this assessment. I hope it was helpful.